In class. I hope you are doing well. Yes. In our last class, we were looking at exponential equations leading to what linear equation, or how to transform exponential equations into linear equations. Today we'll be looking at how to transform exponential equations into quadratic equations. Okay. So if you are given an example like 3 raised to the power 2x minus 30 to bracket 3 raised to the power x is equal to 8 minus 8 plus 81 plus 81 is equal to 0. When you are given an example like this, you need to take your time. Remember, when we were doing the laws of indices, we never met subtraction or addition. Okay, so for most times, if you see a question and you see subtraction and addition in it, the first thing that should cross your mind is that we are going to convert it, or we can transform that exponential equation into a quadratic equation. Looking at this equation, I can see a similarity. I can see 3 raised to the power x here. I can also see a form of 3 raised to the power x here. This one I can convert it to 3 raised to the power x. So what I'm going to do is that I'm going to rewrite the equation and then write it in a form of 3 raised to the power x. Okay, what I mean by that is that this 3 raised to the power 2x can be written as, using the power law, it can be written as 3 raised to the power x or raised to the power 2, see, minus 30 to bracket 3 raised to the power x plus 81 is equal to 0. Okay, so now that I have 3 raised to the power x standing alone in my equation, I can say that I can let any variable, so I can say let a be equal to what? 3 raised to the power x. What it means is that wherever I see 3 raised to the power x, I can put a there. Okay, so substituting a into the equation, I'm going to get a squared minus 30a plus 81 is equal to 0. Okay, so at this point, I've been able to convert or transform my exponential equation into what? A quadratic equation. Okay, so I will then proceed to solve my quadratic equation. Okay, so if I have a squared minus 30a plus 81 is equal to 0. Remember, I'm just going to look for the factors of 81. That is going to give me, when I add, is going to give me negative 30. So it means that negative 3 and what? Negative 27. So we can say that a negative 27, a negative 3 is equal to 0. Okay, so I'll say a is equal to 27, or a is equal to 3. But remember, it's not a that we are looking for. We are looking for what? X in the original equation. Okay, and you know that we said that we should let a be equal to 3 raised to the power x. Okay, therefore it means that what? A, which is 27, will be equal to 3 raised to the power x. Okay, then we can use transforming to linear equations, exponential equations to linear equations to solve this. So 27 is the same as what? 3 raised to the power 3 is equal to 3 raised to the power x. And say, since the bases are the same, x equal to what? 3. Okay, then we can also say that 3 for the 3 is equal to 3 raised to the power x. And 3 is the same as 3 raised to the power 1 is equal to 3 raised to the power x. Since the bases are the same, x is equal to 1. Okay, so we say that therefore x is equal to 1, or x is equal to 3. Exactly. Yes, so like I said, you need to find the common exponent. Okay, the common exponent was 3 raised to the power x. Represent the common exponent by a variable, and then what? Substitute and then solve. Okay, so we'll take another example. So let's say we are given something like 2 raised to the power 2x plus 2 minus 9 into brackets 2 raised to the power x plus 2 is equal to what? 0. Okay, So same for this question. This question as well, we are going to look at the common exponent. Okay. The common exponent is 2 raised to the power x. Okay. So we are going to find a way of writing this one in the form 2 raised to the power x. Let the 2 raised to the power x stand alone. Okay. According to our laws of indices, this one is the same as 2 raised to the power 2x times 2. This will give us minus 9 to bracket 2 to the power x plus 2 is equal to 0. Okay, 2 raised to the power 2, sorry. So this will give us 4 to bracket 2 raised to the power 2x minus 9 to bracket 2 raised to the power x plus 2 is equal to 0. Remember, we are going to rewrite this to be only 2 raised to the power x. So this is going to give us 4 into bracket 2 to the power x all to the power 2. So that the x multiplying the 2 gives us 2x minus 9 to bracket 2 to the power x plus 2 is equal to 0. Then we can say that let a be equal to what? 2 to the power x, so that we can get 4a squared minus 9a plus 2 is equal to what? 0. Okay, so now I've been able to what? To convert my exponential equation into what? A quadratic equation. So now we'll proceed to solve it. So we are going to get 4a squared minus 9a plus 2 is equal to what? 0. Okay, when we solve this one, we are going to end up getting 4a minus 1, and then a minus 2 is equal to 0. We end up getting a is equal to 1 over 4, or a is equal to 2. But remember, we said that we should let a be equal to what? 2 to the power x. Then what it means is that 2 to the power x will be the same as 1 over 4. This will be the same as 2 to the power negative 2. Say x is equal to negative 2. And say that 2 to the power x is equal to 2. 2 to the power x is equal to 2 to the power 1. Since the bases are the same, make sure you write since the bases are the same. We'll see that what? X is equal to 1. Okay, therefore our answer x is equal to 1, or x is equal to negative 2. Is that clear? Yes. So we solve our last example, which looked quite difficult. Okay, but we are still going to solve it. Okay, so let's say you are given another example: 3 raised to the power 2x minus 3 into bracket 3 raised to the power. So let's write the question again. So 3 raised to the power 2x minus 3 raised to the power x plus 2 plus 8 is equal to 0. Okay, remember, we are always going to look for the common exponent. Our common exponent once again here is 3 raised to the power x. So we are going to rewrite them to let the 3 raised to the power x stand alone. So we are going to get 3 raised to the power x all raised to the power 2 minus, according to the laws of indices, this is 3 raised to the power x times 3 raised to the power 2, since the bases are the same, we add the exponent, plus 8 is equal to 0. So we get 3 raised to the power x all squared minus 3 squared is 9 to bracket 3 raised to the power x plus 8 is equal to 0. So if we say let a be equal to 3 raised to the power x, you can get a squared minus 9a plus 8 is equal to what? 0. Okay, so now we have our quadratic equation. Okay, so we are going to solve this quadratic equation. Remember, a squared minus 9a plus 8 is equal to 0. Okay, so we are looking for the factors of what? 8, that will give us negative 9. That is what? Negative 1, and then what? Negative what? 8. Okay, so we end up getting 8 equal to 1, or 8 equal to 8. But remember, we said that a is equal to 3 raised to the power x. Then what it means is that 1 will be equal to 3 to the power x. So we'll say that 1 is the same as, remember, 3 raised to the power 0 is equal to 3 to the power x. Then we can proceed to say that what x equal to 0. Now we also say that 8 is equal to 3 raised to the power x. Okay. Now can we write 8 as 3 raised to the power something? No. So at this point we are going to apply logarithms. Although you have not done logarithms, you are going to see that soon. Okay, so according to your book, you just realize that we take log 10 of both sides. So we'll say log base 10 of 8 is equal to log base 10 of 3x. Okay, this keeping our log base 10 of 8 is going to give us x log base 10 of 3. Don't panic, we are going to do that in logarithm. So we are going to say that x is equal to log base 10 of 8 over log base 10 of 3, and x is going to give us 1.89. Okay, forget about the logarithm aspect. When we get to logarithm, we are going to see how to solve an equation like that. Okay, so from this lesson, it's simple to be able to convert exponential equations into quadratic equations and solve. Remember, all you need to do is to find your common exponent and how to convert it, and represent it by a variable, substitute it, and then solve your quadratic equation. Okay, have a nice day. Thank you.